Hello 8th graders, this video is to show you how to calculate using Newton's second law, and this is ELR 3.5. And I want you to imagine this just like what we did in class with the pulleys lab. For this one, we've got a picture on your notes, same as I have on my screen. Newton said basically if you have two vessels, two wagons, that are each carrying a mass, and one has a big mass, one has a small mass, and let's say that you pull on the wagons with the exact same amount of force in both scenarios, the one with the smaller mass is going to speed up in a much quicker way than the one with the bigger mass in it. So in other words, if you put two different objects with different mass but the same force, the larger one is going to speed up slower. And this is no surprise. This is what we found out in our lab. Just now we're going to actually do some calculations with an equation. So that equation is force equals mass times acceleration. And you can kind of think of this as the amount of force to make an object speed up or slow down is equal to the mass of the object and how much you want it to speed up or slow down. So in other words, if you want something to go, some massive object to speed up, you're going to have to apply a force. So force is equal to the mass times the acceleration. So let's do some practice examples. Oh, sorry, I forgot about this triangle. So for this, just like we've done in other ELRs, this triangle is going to work for the same way if you want to solve any part. Remember, all you have to do is cover the part of the triangle that you're solving for, and it's division if they're on top of each other and multiplication if they're side by side. So suppose that you have a box that is 30 kilograms, and that box is speeding up at 2 meters per second per second. We have an acceleration and we know how much mass it is. A question like this would be, how much force is it going to be required to make the box do this? So suppose you have this box and you want it to speed up at 2 meters per second per second. Well, how hard are you going to have to push? That's what we're solving for. Well, we're going to start with our equation, force equals mass times acceleration, and we're just going to plug in what we know. We know the mass, we know the acceleration. Now we're solving for F, so we just got to do 30 times 2. Our force is going to be 60 newtons. So you're going to have to push with 60 newtons of force to make this 30 kilogram box speed up at 2 meters per second per second. Let's try one where we're solving for something else. Let's say we have the same 30 kilogram box, and this time we're saying that somebody is pushing on it with 50 newtons of force. So this time we don't know the acceleration. We know how hard somebody's pushing and we know how big the box is. I just want to know how fast it's going to speed up. So how much will this box accelerate? Well, we're going to start with sort of the same equation. If I go back to my triangle and I'm solving for acceleration, if I cover the acceleration, it becomes force over mass, force divided by mass. So my acceleration is equal to force divided by mass. Again, I'm just going to start plugging in the things that I know. I know the force, I know the mass, so I've got to go 50 divided by 30. When I throw that into the calculator, I'm going to get 1.67, make sure you pick the right units, meters per second per second. Now on your sheet, you're going to go and do some of the apply questions, and they look like this. I want you to suppose that you have a rocket that you want to shoot up into space, and Mr. Knox tells you that it's going to need 9 meters per second of acceleration in order to get up into space, and the motor that you have on your rocket can provide a force of 85 newtons. So we need to figure out, if this is the case, you need to go this fast and it only has this much push, we need to figure out what's the biggest mass that you can have on your rocket. Like how much of a payload can you have, how many passengers, or how much extra stuff can we put on that rocket. So I need you to please start with your equation and attempt this problem on your paper. Check your answers in the front of the room when you're done. And if that one is too easy for you, when you're done, I want you to try this question. So I'm assuming if you're looking at this question, you've already tried the first one and checked your answer. For this one, you and your friend are pushing a car, but you think that maybe your friend is slacking off and he's not pushing as hard as you are. So you know that the mass has the mass of the car has 800 kilograms, and you know that the car is speeding up as you and your friend push at this rate, 1.9 meters per second. And you know how much you're pushing with. Let's say you're pushing with 950. I want you to figure out, how are you going to find out how much force your friend is pushing with, and here's how you're going to do it. If you have an idea, please pause this video and give it a shot. And if you're listening at this point right now, I'm assuming that you are stumped and you need some extra help. Otherwise, you've already tried this. So here we go. In order to do this, what you're going to do is you're going to say, all right, 950 plus what? Like plus x is equal to the force in that same equation. So you're going to plug in 950 plus x into the f part of the equation, and then we have the mass and we have the acceleration on the other side, and then you can just use algebra to solve. Once you have tried that out, please check your answer for this one at the front as well.